SKA is basically an intergovernmental organization including more than 13 countries. It's aiming to build world's largest radio telescope. The square kilometer in the SKA means that the total effective collecting area of the telescope will be of 1 square kilometer. That is 1 million square kilometer. And the biggest telescope that we have right now in China has a collecting area of 78,000 meters, while the SKA will have a collecting area of 10 lakh meters squares. So that's quite big. Now the three basic questions that arise are why, how and where. Why do we need to build such a big telescope? Now we know the bigger the wavelength of the wave, the bigger the size of the antenna is required to detect it. And the radio waves have the longest wavelength in the whole EMT spectrum. So to detect radio waves, we need to build telescopes as big as possible. So this is a model of SKA. SKA has two phases. In phase 1, there will be over 300 mid-frequency antennas installed in South Africa, and over 125,000 low-frequency antennas installed in Australia. That's for phase 1. Now in phase 2, we will install 3,000 mid-frequency antennas in South Africa and over 1 million low-frequency antennas in Australia. And this will span over an area of 3,000 kilometers. So why specifically Australia and South Africa? Because they have the best view of the Milky Way galaxy on the Earth. Also, we need to build the telescopes in a radio quiet zone, the zone with minimal to zero radio interference. Radio interference is basically the radio waves that are emitted from our day-to-day equipments like cell phones, televisions, TV antennas. Every equipment emits a radio wave. So those radio waves could act as an interference for the actual data that we are trying to gather from the space. So they have to be in completely remote areas with lowest population density. So that's the basic structure of the SKA. Now, what are the big aspirations that scientists have in mind to use the SKA for? You can see here some basic projects are the cradle of life. Like whenever a star or a new planet is formed, what are the chemical processes and reactions going around it? What is the environment around it? We could detect that using the SKA. We could cast those radiations and actually tell what's happening around there. Now second, this one is the most exciting part. We could actually time travel. We are going to take a picture of the events that happened during the formation of earliest stars. Now when the Big Bang happened, there was nothing but a neutral hydrogen cloud for many thousand years. But when the formation of early stars began, it ionized the hydrogen and released radiation. Those radiations are still coming to us, and we could catch it using the SK only, because the current biggest telescope that we have in China, that too is not capable of detecting those signals. So yes, we could catch those signals using the SK and actually say what was actually happening during the formation of the universe. So that's a big mystery to be unraveled. We could also prove the Einstein's theory of relativity to much greater extent. We could test it to much greater extent. Now there are always there is dark ages. There are ages after the Big Bang when there was nothing, no light, no radiations, just only matter. We could detect some radiations originating from that area. Then how did the universe become magnetic? Where and when did magnetism originate? We could detect the radiations and actually answer some big questions in cosmology and dark energy. The new radiations, many different radiations that were earlier undetected, and possibly we could account for the dark energy. Now, what is the contribution of India in this? Now, India already has the SK Pathfinder in India as GMRT telescope. This one is a model of a single dish of GMRT. It is 45 meters in diameter, and there are over 30 such dishes located in Pune in India. And scientists have already gathered so much information using these telescopes. So the working of SKA and GMRT is almost the same. So India already has an experience in this field. Hence, India was provided one of the main tasks of the SKA. India will be the nervous system of the SKA. India will control the telescopes and collect the data. And most importantly, we are creating a software to process those data. Actually, the amount of data that would be transferred from these telescopes is 1 petabytes per second. So that's a huge amount of data. So to process those data and store them, we need to build a very strong software, and also the supercomputer that we are going to use for it is going to be 25% faster than any of the current fastest supercomputers. So, and these are the current members of the SK. You can see Australia, Canada, China, France, Germany, India, Italy, New Zealand, South Africa, and many more. And these are African partner countries. So India was associated with SKA in 2015. Here is Dr. R.K. Sinha, SK Director General, Professor Philip Diamond, signing the Memorandum of Understanding. India's duties will be telescope manager. We are going to provide scientists and earlier data that we gathered from GMRT that could be useful for the SK. You can see the amount of data that will be transferred. Every year, the volume of data stored by the SK would fill over 1,500,000 GB laptops. Also, as I said, the supercomputers will be 25% better than the current ones. This is all about SK. So yeah, SK could open a big field of opportunity for us, and many earlier questions that were unanswered could be answered by the SK. So it's a big breakthrough in the field of radio astronomy. Thank you.